In welding, one small detail can decide whether a structure lasts 20 years or fails under pressure. And that detail is the type of joint used to connect the metals. Many beginners focus only on the welding machine, the amperage, or the electrode, but experienced fabricators know something deeper. The strength of every weld starts with the joint itself. The American Welding Society, AWS, classifies welding joints as the way two metal pieces are positioned and fitted together before welding. And across every fabrication shop, shipyard, pipeline project, and structural build, there are 5 fundamental welding joints that dominate the entire industry. These are butt joint, T-joint, corner joint, lap joint, and edge joint. Each one behaves differently under heat, stress, and load. Each one demands a different technique. And each one tells a story about how modern welding has evolved from manual craftsmanship to today's precision-controlled automated fabrication systems. Because in 2026, welding is no longer just sparks and steel. It is robotics, digital control, advanced metallurgy, and engineered precision. So, in this guide, we break everything down in a way that is simple, practical, and industry-focused. So whether you're a beginner or an experienced welder, you understand not just what these joints are, but why they matter in a real-world fabrication. Let's dive in. What is a welding joint? A welding joint is the location where 2 or more metal parts are positioned together before welding. Think of it as the connection design before the actual weld is applied. If welding is the glue, then the joint is the shape and structure of how the pieces are held together. And here's where most beginners underestimate things. Different joint types affect strength of the weld, heat distribution, penetration depth, stress handling capacity, and risk of cracking or failure. That's why AWS emphasizes mastering joint types as a foundation of welding skill development. Because before you even strike an arc, you are already designing the strength of the final structure. The 5 types of welding joints. Let's break them down one by one with real industrial meaning and application. Butt joint. A butt joint is created when 2 metal pieces are placed edge to edge in the same plane. No overlap, no angle, just a straight connection. This is one of the most commonly used joints in fabrication and pipeline work. Where butt joints are used? Pipe welding, structural steel fabrication, pressure vessels, shipbuilding, automotive frames. Why it matters? Butt joints are designed for direct load transfer, meaning force flows straight through the weld. But because of that, they require proper edge preparation, accurate alignment, and full penetration welding in critical applications. Modern advancement? Today, CNC cutting and laser edge preparation have improved butt joint precision dramatically. And in pipeline welding, automated orbital systems ensure consistent root penetration with almost 0 human variation. T-joint. A T-joint is formed when 2 metal pieces intersect at 90 degrees, creating a T-shape. Where T-joints are used? Structural frames, machine bases, reinforcements, industrial supports. Why it matters? T-joints handle shear stress and load distribution, making them critical in construction and heavy fabrication. The most common weld used here is the fillet weld, applied on one or both sides. Modern advancement? Robotic welding arms are now widely used for T-joints in manufacturing lines, especially in automotive chassis production. AI-driven weld path programming ensures consistent bead size and penetration across thousands of joints per shift. Corner joint. A corner joint is formed when 2 metal pieces meet at a right angle, forming an L shape. Where corner joints are used? Frames, boxes and enclosures, sheet metal fabrication, structural housings. Types of corner joints: open corner joint, closed corner joint. Why it matters? Corner joints are essential in forming structural shapes like tanks, cabinets, machine housings. They must handle stress from multiple directions, especially in load-bearing frames. Modern advancement? Modern fabrication uses laser-guided alignment systems to ensure perfect 90-degree precision before welding, reducing distortion and rework. Lap joint. A lap joint is created when one metal piece overlaps another. Instead of edge-to-edge contact, the materials sit on top of each other. Where lap joints are used? Sheet metal fabrication, automotive body panels, roofing structures, thin metal assemblies. Why it matters? Lap joints provide large surface area for welding, strong bonding under shear load, and good resistance to vibration. They're especially useful when working with thin materials that cannot support deep penetration welding. Modern advancement. In automotive factories, resistance spot welding robots now create thousands of lap joints per hour with near-perfect repeatability. This has revolutionized mass production efficiency. 5. Edge joint. An edge joint is formed when two metal edges are placed side by side and welded along the edge surface. Where edge joints are used: sheet metal boxes, light-duty containers, pressure-free assemblies, decorative fabrication. Why it matters? Edge joints are not designed for heavy structural loads. Instead, they are used for sealing edges, preventing leakage, and light fabrication work. Modern advancements. With modern TIG welding and microplasma welding systems, edge joints can now be produced with extremely clean finishes, especially in stainless steel and aerospace-grade fabrication. Comparison of the 5 welding joints. Each joint has a different role in industry applications. Butt joints, strongest linear connection. T-joints, structural load distribution. Corner joints, frame construction. Lap joints, overlapping strength and flexibility. Edge joints, sealing and light fabrication. No joint is better than the others. They're simply designed for different engineering needs, and modern fabrication relies heavily on selecting the right joint before welding even begins. Modern technological advancements in welding joints. Welding today is not what it used to be. The industry has evolved with 1. Robotic welding systems used in automotive and aerospace production for perfect joint repetition. 2. AI weld monitoring detects joint misalignment, heat imbalance, and penetration issues in real time. 3. Laser joint preparation ensures extremely accurate edges before welding begins. 4. Orbital welding technology produces flawless butt joints in pipelines and sterile systems. 5. Digital welding simulation allows engineers to test joint performance before physical welding starts. These advancements have turned welding into a high-precision engineering discipline, not just manual metalwork. Common mistakes welders make with joints. Even experienced welders sometimes make errors such as poor joint alignment, incorrect joint selection, inadequate penetration, ignoring heat distortion, weak edge preparation. These mistakes often lead to weld failure, structural weakness, rework, and increased cost. Understanding joints properly eliminates most of these problems before they even happen. Why mastering welding joints matters. If you want to grow in welding, fabrication, or industrial technology, mastering welding joints is non-negotiable because every structure you see around you, bridges, cars, pipelines, machines, buildings, all depend on these 5 fundamental joints. And professionals who understand them don't just weld, they engineer strength. Conclusion. Welding is not just about melting metal together. It is about controlling structure, force, and durability through proper joint design. The 5 welding joints, Butt, T, corner, lap, and edge form the foundation of every welding process used in modern industry. And as technology continues to evolve, from robotic automation to AI-driven welding systems, the importance of understanding these joints becomes even greater. Because no matter how advanced welding machines become, the quality of every weld will always start with one decision: choosing the right joint. Master that, and you don't just become a welder, you become a builder of strength, precision, and reliability.